Hello. So, we will continue our discussion or lectures on cloud computing. Today, we will take up a topic which is we need to look at that what is this economy behind cloud computing, why people will go for this cloud computing type of things, right. What it is not like that we are getting a something totally new. So, it is only that the different type of application etcetera now we are getting as a services. So, it is what makes this or what will make this viable. Is it always going to cloud is beneficial, or where how to decide that whether I need to go to cloud or whether I need to buy something in house, and how to balance between in house infrastructure and provisioning of the cloud. So, in order to do that, we will try to see some basic phenomena or basic economic point which is makes cloud viable at which type of operations or which type of situation type of things. So, we try to look out that when a organization or individual, especially organizations wants to switch over cloud partially or fully, what are the consideration it should keep in mind. We have seen SLAs, we have seen there are other issues that even during cloud our initial lectures, that there are some limitation, there are some issues with the cloud, but keeping all that, even all those things are running fine, whether it is economically to be on cloud always or at times or at what times and type of things, and what should be the consideration. So, we will have a brief discussion on that. So, those of you are interested in working on this line can basically now leverage on this type of work. So, from the economic point of view, if we see that what are the different cloud properties, relook at the properties, one is the common infrastructure. So, pooled standardized resources with benefits generated by statistical multiplexing, right. So, that is important. First of all, it is a pooled standardized resources. So, at the service provider end, it is a pool of resources which are standardized how they can be integrated etcetera, right. What is the benefit from the thing? Because of multiplexing tasks, right. So, statistically multiplexing benefit generate statistical multiplexing, that means I have some 100 systems, right. So, it is highly underutilized, even 15-20% are not utilized of my own workload. So, or from some workload. So, if I have multiple workload, I may with the same type of system I can go up into the things. What I am thinking that why I have purchased this some 10 or 100 systems, because considering most of the cases we have considered a peak workload, right. At peak time I will be requiring all those things, right. Say for example, IIT Kharagpur in a particular department, a particular lab for a particular year, say MTech first year, the number of seats are say 50 for a particular department, and what we expect that 50% will do work on 50 individual system. We purchase a lab of we basically set up a lab of 50 systems. Adjoining we same time we have to go for power, at the same time we have to go for AC, and we feel that if there is a system goes out and type of things, keep another 5-10% another 5 system on a standby. So, having 55 systems, but it may so happen that that year the recruitment the number of students join the course may be less than 50. So, I have any surplus power, even they join the courses, right. These 50 system are again underutilized, may not be utilized all the things during the lab hours, maybe daily 8 hours it is utilized, otherwise things are not there, right. One is looking at the peak load. So, but whenever I consider the system individually, I have taken this processor, memory etcetera, thinking this lab assignment will be leading up to that level. So, that means at the peak load, right. So, this consideration may be at many times I do lot of over sizing of the things, and if I have it becomes more critical when I have a server, a single server which is catering to number of users, and then I think that all the user will jump into the thing, right, and then the peak load will be there. right. If those who are working in the networking, you might have seen that typically 24 port network switch, right. How many people can connect? 24. Even 100 Mbps line, so it is 24, roughly 24 into 100 if we not go to the nitty-gritty of this binary thing. So, it is approximately 2.4 gigabytes, but the switch uplink will be maybe 1 gigabyte. So, it is some sort of a blocking architecture, but if I give a uplink of 2.4 or 3 gigabyte, then it is over provisioning, right. It is all the people are coming statistically at the same peak time may not be there. So, statistically we need to look at that whether it is viable to provision such a higher thing. When we provision higher thing, it involves lot of costing and other things into the things, maintenance of the thing, there are things of adjoining other accessories, etc. Even the cost of the equipment goes up and so on and so forth. So, that is one thing. Another is the location independence, that is another property of cloud, like ubiquitously available meeting performance requirement with benefits deriving from latency reduction and user experience enhancement. So, this is a location independence property. So, whether it is economically how to make use of that. Online connectivity as an enabler of other attributes ensuring service cost and performance impact on the network architecture, etc. So, I should have a online always connectivity. So, that is another factor. So, these are the different factors which may force us to look at the different things. There are other two direct economic factor, one is the utility pricing, right. I pay as you go model, I pay per unit things like electricity, etc. There is another thing called on demand resources. So, when I demand for the resources are provisioned, right. So, it is on demand, I demand for the resources are provisioned. So, scalable elastic resources provision and deprovision without delay and cost associated with the change, right. So, there cannot be delay or cost associated with the thing, there may be cost factor, rather there should be minimal human or managerial involvement. So, that as I go forth and things like my resources provisioning and deprovisioning should be there. So, with this we want to try to find out this valuation of this or whether there is economic point of view. We try to look at little bit statistically, very little portion of the thing to understand this issue. One is economics of scale, reduced overhead cost, buyer power through volume purchase, right. One is that one is the economic scale means I want to reduce this overhead cost, right. So, what are the different overhead costs? Like if I buy a system, it has a overhead cost of AC, it has a overhead cost of power maintenance like UPS or type E, it has overhead cost of AMC of the system, right, and there are several other of like human resources to maintain the thing, etc. So, I want to reduce that overhead cost, right. So, buying the thing is still okay, but maintaining the thing at times becomes over the years much costly than the equipment itself, right. And there is a major problem of especially for in the computing world, that after typically 2 to 3 years, not more than definitely within 5 years, that whole thing becomes obsolete. The technology becomes obsolete, the whole system power, etc. is no longer valid for no longer becomes viable for installing new set of tools and software, etc. So, that is a big problem. There is a statistics of scale on the other end for infrastructure built on peak requirement, like infrastructure build of peak requirement. I think that I build a infrastructure that always all my students will be there in the class or all will register for the course and etc. So, multiplexing demand may help me higher utilization, right. So, when I have huge things, then multiplexing different demand may help me higher utilization, lower cost per deliver resources than unconsolidated work. So, it is a lower cost per deliver resources than if there is a unconsolidated workload. So, if it is a consolidated and lower cost will be there. So, for infrastructure build to less than peak. So, it is not peak, less than peak. Here also multiplexing demand reduce the unserved demands, right. So, multiplexing. So, there may be, if it is a blocking architecture, there can be some of the things which are not served. So, multiplexing may reduce this unserved things. It is not like that it is that one it is always biased to the one, I go on some sort of a scheduling algorithm and go on serving everyone. lower loss of revenue or a service level agreement violation, because SLA violation means you need to pay out something, SLA violation payout. So, it may reduce lower loss of revenue and etcetera. So, both for peak infrastructure built on peak and non-peak, we have this sort of things. Another term which comes not only for cloud, for any type of this type of things where risk is involved and you have to give services, what you say, coefficient of variance or commonly CV. So, it is not exactly covariance we are talking about, coefficient of variance. So, a statistical measure of the dispersion of data in a data series around the mean, right. Like a coefficient of variance is represented by the ratio of the standard deviation of the mean to the mean. So, it is standard deviation, or those who are sigma to sigma by mu, right, it is standard deviation by mean, and it is useful statistics for comparing the degree of variation from one data series to another, right. So, I can say that this, whether the coefficient of variation of this data series is more than, less than, equal to other data series, is this is a good measure to look at it, right. Rather, even if the means are drastically different, then also we can compare two data series. So, how these two data series behavioral things are there, the CV gives me an idea to do that, right. So, it is widely used or widely looked into in the investing world. So, in a investing world, coefficient of variation allows you to determine how much volatile or risk you are assuming in comparison to the amount of return you can expect from your investment. So, this CV gives you an idea that how much risk you are assuming in comparison to the amount of return you can expect from the investment. So, ROI, how much risk you are involving. So, this is important. If you see, it is also important in our this sort of scenarios also, like we are basically involving some risk by leverage, by putting my organizational from means infrastructure or from the on-premise infrastructure, so cloud infrastructure. So, there is a risk of that if the infrastructure is not available and so and so. So, it is not only infrastructure, I want to mean to say that all type of services on the cloud thing. So, if the service is not available, so how much risk I need to take on those things. So, in simple language, lower the ratio of standard deviation to mean, the better is your risk return trade off, right. So, lower the ratio to standard deviation to mean return, so the better is the risk. So, I can have more smoothness into the curve, that is important. So, it is a some sort of a measure of smoothness. So, if it is a very variable load or there are a lot of peak and non-peak things, then I am in much bigger trouble in measuring that how things will be there. If it is a smoothing out load, then I am much in a better position to do that. So, coefficient of variation CV, as you say that it is not similar as variance nor correlation coefficient as we are mentioning, ratio of standard deviation to sigma to absolute value of the mean mu or mu mod. So, smoother curves, large mean for a given standard deviation. So, as we are telling the sigma by mu, if it is a large mean, then given standard deviation things will be not varying that much, or a smaller standard deviation or of a given mean, then also things will be much under control. So, importance of smoothness, a facility which fixed asset servicing highly variable demand will achieve lower utilization than a similar one servicing relatively smooth demand, right. I am a service provider, I have some 100 systems at my backbone and I know that the demand will be something smooth, right. Then I can basically have a better management of the things, or I have n number of systems. So, what will be the value of n is much easier, but if it is a very much varying, suddenly demand goes up 100, then 10 etcetera, then I have a problem, right. Similarly, for any, if you look at our day to day life, any shopkeeper, the amount of provisioning he will do he will keep in its store is depends on the demand thing. If the demand is something smooth, it may vary, that Monday demand is different from Tuesday demand, different from weekdays to weekends demand, etcetera, fine, but he has the idea. But it is totally random or you can't do anything, then it is very difficult to provision the things. So, that is the same thing holds there. So, multiplexing demand from multiple sources may reduce the coefficient of variation, right. that is the thing. So, now I cannot predict that what are the different sources, how things will be there, but if I could have multiplexed the different demand for multiple sources. So, it may so happen that may happen that this multiplex thing may have give me a better CV, right, which may have a little smooth CV where the overall demand things are there. It is not like that all are going peak at the time, all are coming down at the lower things, but I have a multiplex type of things. Like if we look at say x1, x2, xn are independent random variables of demand, identical standard, say for our argument's sake they are having, though they are independent and random, but they have something identical sigma and mu. So, aggregate demand in case of mean, sum of the means n mu, aggregate variance is n sigma square. So, if we calculate that coefficient of variance, it is 1 by root n CV, right. So, if n increases, I multiplex more, then the 1 by root n decreases. So, I have more smoothen out this coefficient of variation or smooth type of curve. So, adding n independent demand reduces CV by 1 by root n. So, it becomes more smoothen out. So, penalty of insufficient excess resources goes smaller, right. So, what is happening if it is smooth now, then I do not have to penalty, I have to keep more resources at my back end, right, it reduces, right. Otherwise, I do not know whether it is a 10 demand of 10 units or 100 units and etcetera, and then I have to keep a track of 100 units at the back end. Like aggregating 100 workload bring the penalty down by 10%, 1 by root over 100 is 10. So, it may bring down the whole thing by 10%. So, aggregating multiple resources may allow me to have a reduced loading. But what about the different workloads? Non-negative correlation demands, like if x and 1 by x sum of a random variable is 1, appropriate selection of the customer segments, right, is another important thing, right. I say that I have a computing infrastructure, I select those customers, some of them are active on daytime, some of them processings are active on the night time, right. So, it is compensating, right. If the both are working at the same time, then the peak will go much higher, but selecting that negative demands or the time in the time scale, I could have managed those things with the same infrastructure. So, that selection of the customer base is the important things, what sort of things will be there when I go on selecting customers. Perfectly correlated demand, if some of the things are perfectly correlated, the aggregate demand will be n x, variations will be n square sigma square x, and mean will be n sigma and standard deviation so and so forth. Coefficient of variation remains constant. So, it is perfectly correlated demand that this thing will be as a constant. There are third issue, if all demands are coming at the peak at the same time, all at the peak at the same time, then I have a serious problem, right. Then I have a congestion at the things, all are demanding at the same time. Like if I say all classes are breaking at the hourly basis. So, at the hourly basis we have a huge demand for this road network, right, lot of vehicles like starting for cycles to etcetera are on the demand, because all classes are things. So, it is a peak coming to the thing at the same time, right, then we have a problem. So, common infrastructure in our real world. So, correlated demands, private, mid-size, large size providers can experience similar statistic scales. So, it is a more or less correlated demand. Independent demand, mid-size provider can achieve similar statistical economy to an infinitely large provider, right. Available data on economy of scale for large provider is mixed, right, because use of same COTS type of things, that is commercial off the shelf systems and components, locating near cheap power supplies, that is one thing. Like if as the power supply is a major thing for the data centers, they want to build the data center where the power supply will be much cheaper and nearby. Early entrant automation tool, third parties takes care of it. So, there can be early entrant automation tools which the third party can be taking up. say value of, there is a value of value corresponding to the location or value of location independence. We used to go to the computers, but the application services contents now come to us, right. So, there is a paradigm shift, like say yesterday's, or we used to go to the system to work on it. Now, the system power etc. are coming to my own desktop, like. So, I have a large pool of huge resources on my very thin system. It can be a simple desktop, laptop and type of things, all are provisioned here. So, through networks, wired, wireless, satellite etc. But what about latency? So, latency also a big thing, right. So, human response is 10 to milliseconds, 10 to 100 milliseconds. So, latency is correlated strongly with the distance, right. More the distance, more the network latency, and other type of latency will more at the hops, more at the failure rates and etc. So, though it also depends on the what sort of routing algorithms etc. also coming into play. So, speed of anyway we know that speed of light in fiber. So, some particular 124 miles per millisecond. So, if suppose I am searching something and it takes more than couple of seconds, then we are not happy with that. If in a VoIP thing, if it is something delayed more than something 200 nanosecond, 200 millisecond, then it is very difficult to communicate over this voice over IP. So, there is a supporting of a global user base requires a disparate service architecture. So, the architecture, if I want to support, if my provider is to support all the global user base, then I have to have a appropriate distributed and dispersed architecture to do that, and similarly the protocol. So, coordination, consistency, availability, partition, tolerance, these are issues. So, and it has a direct implication on investment, that what sort of investment we want to do. We like to look at another aspects of the thing, what we say value of utility pricing, right, that how things will be priced, how things will be there, how I can provision system, and it may also help me to look at that whether it is useful to be go to cloud or having something at your own premises. So, economy of scale might not be very effective always, means all taking consideration, right, but cloud service do not need to be cheaper to be economical, right. So, it is economic of things may be based on that my requirement etc. What sort of demand I am giving. Like if we, the popular example people used to give is that consider a car. So, buy or leasing a car may cost me something 500 per day, right, whereas renting a car may be say for example 5,000 per day, right. So, when it is economical, suppose I by looking at it always the buying the car may be economical, but if I am commuting say a large distance or say once in once in a month or couple of days in a month, then buying a car may be more costly than renting a car. But if I require that car on a daily basis, that going to my workplace, traveling a large distance etc., then the buying a car will may be economical than renting a car, right. So, it all depends that what sort of demands you are having. So, we will just to do some simple mathematical expression, little bit simplified, so that to have like suppose I have a demand dt. So, demand varies over time 0 to capital T 0 to time. So, demand for resources dt, P is the max demand or peak demand, okay. A is the average demand. So, average over the time scale. B is the baseline or owned unit cost. So, if I have owned a unit cost, what is the baseline cost? C is the cloud unit cost. So, what is the cloud unit cost if I purchase the thing, and U utility premium, rent a car for that there is some typo. So, there is rent that car maybe something it will come whatever in our case is 5,000 by 500. So, something 10 is the utility here. So, utility of the premium is that taking a cloud service divided by the baseline service, right. That is the utility premium we are having the things, right. That is the utility premium. Now, so I have a variable demand dt, I have a peak demand P, we have a average demand A, there is a baseline owned unit cost B C, cloud unit cost C, and I want to find out the utility premium, that is C by B. Now, if I want to see the overall cloud cost, so U into B into dt integrating 0 to t is the overall cloud cost, which is somewhat U A B T is the overall costing of my cloud. If I want to calculate the overall baseline over time t, so P, that is the peak demand, into, because whenever I am going for baseline I have to go for the peak demand thing to calculate the thing. B is the baseline own unit cost and T is the overall time scale. Now, when cloud is cheaper, when the CT is less than BT, if the cost of cloud is less than the cost of baseline, then it is cheaper. So, or in other sense, if you look at it very simplified form, so when P by A is greater than the utility premium, right, peak cost by average cost, peak demand by average demand is greater than the utility premium. So, when the utility premium is less than the ratio of peak demand to average demand, then your cloud may be cheaper than owning the infrastructure or owning the services. So, utility pricing in real world, in practice demands are often spiky, like news stories, suddenly it came into things, market promotions, product launches, internet flash flood, something goes to the internet, etc. Some seasonal things like Christmas, tax, so those things goes up. Often hybrid model is best, like you own a car for daily commute, but rent a car when traveling or when you need a larger distance to move. Key factor is again the ratio of peak to average demand. So, key factor is there again, that what is the ratio between the peak to average demand. But we should also consider other costs, like which are not considered in the previous calculation. There are network cost, both fixed and usage cost, interoperability overhead, like different one information, one data is talking to other, there are interoperability overhead. Consider reliability, accessibility and so on and so forth, right. So, these are the different factors. Another aspect we will just quickly see is the value of on demand services. So, simple problem, when owning your own resources, you pay the penalty whenever the resources do not match with the instantaneous demand. Suppose I have 100 resources and I pay the penalty when it is underutilized. Suppose it is utilized with 80%, 70%, then I pay the penalty for the rest of the 10 to 20, 30 things, right. Either pay for unused resources or suffer penalty of missing service delivery, things are there, right. So, if it is or if it is higher things, then I do not able to service. So, penalty is, how do I calculate? Penalty is proportional to the demand, instantaneous demand minus instantaneous resources integrate over time t, right. If demand is flat, penalty is 0, right. If demand is linear, periodic provisioning is acceptable, right. If it is a linear, then periodic provisioning is acceptable. If the demand is non-linear, then periodic provisioning in cloud is a big question, right. Suppose if the demand is exponential, like in this case dt equal to e to the power t, right, any fixed provisioning time interval Tp according to the current demand will fall exponentially behind. Suppose I require time Tp to provision the things, right. By the time I provision, it has gone up. So, it goes on. So, this RT equal to E of t minus Tp, this time that time to provisioning Tp will create a havoc, right. So, dt minus RT equal to k1 dt if you say. So, penalty of cost is C k1 e to the power t. In other sense, this penalty grows exponentially. It is extremely difficult to match this unless you over provision and try to look at, that is also at times difficult because it grows in exponential things. So, we need to be careful that when what type of demands we are expecting, need to study, and based on that the provisioning should be there. So, based on this I kept a small assignment for you to work at your own time, and we will discuss this assignment in one of these classes during some free time. So, it says that consider a peak computing demand of an organization 120 units and demand of the functions time expressed as this, like these are the demand of with respect to dt is the demand over t. The resource provisioning of the cloud to satisfy the current demand t is at t equal to so and so forth, where delta t is the delay in provisioning extra computing resource on demand. So, this tilde is the delay, right. So, what we say that the cost to provision unit cloud resource per unit time is 0.9 units. So, we want to calculate the penalty if any and draw the inference like why this type of penalty, how things are there and so and so forth. So, we are assuming some of the factors like what should be the delay in provisioning, penalty, it may be either pay for unused resources or missing service delivery and type of things. So, this I encourage you to look at this problem with this thing that how things will be there. We will in subsequent class, one of this class we will discuss this problem. So, that is all for today. So, we looked at the economy of cloud and where it is beneficial and what are the different aspects to which drives the economy of cloud and type of things. Thank you.